Ch3.6 extra practice, dealing with slope, dealing with slope-intercept form, dealing with standard form. Lots of fun things here. So it says in exercises 1 and 2, describe the slope of the line, then find the slope. Well, the slope is a vertical line, so if it's straight up and down, but I don't think that's what they wanted, but that is, then find the slope. So the slope is going to be the rise over the run from one point to another. So we actually have 2 points here, and so when I rise, I go up and down, and when I run, I go left and right. Up is positive, down is negative, left is negative, right is positive. So how do I describe going from one point, well, let's not use that color, going from one point to the other point? Now, I can do this as my first point. This can be my first point. This can be my second point, and then we'll do it again where we flip those. But going from the first point to the second point, up and down, I would go up 1, 2, 3, 4, 5, 6, 7, 8. So I would go up 8, and then how much do I run? How much do I go left and right? Well, I go right 0. So up, as we said, translates to positive, so that's positive 8. Right is positive 0. So 8 over 0 is undefined. What is undefined? Undefined means no slope. That's the more important one. I mean, it's an undefined slope I've seen as the answer, but a lot of people are going to understand that there's no slope there. Let's say that we went from the second point to the first point. And let's see what we would do. We'd go, starting at the second point, you go down 1, 2, 3, 4, 6, 7, 8. So we went down 8, and then we still went right 0 or left 0. It doesn't matter. And down 8 is negative 8 over right 0 is 0. And negative 8 over 0 is still undefined, or no slope. So a vertical line has no slope. That's the important thing that we need to understand. Here we have positive slope, so describe the slope. It's going to be a positive slope. How did I know it was going to be positive? Because moving left to right, the y values are increasing. As we increase our x values, -1 to +3, that's increasing. Notice what happens to our y values. We go from -4 to +4. So our y values are increasing, and so that we know is a positive slope. And if we want to be even more specific, we're going to do the rise over the run. We're going to deal with our y-axis, because slope is the difference of y's over the difference of x's. Y's, it deals with rising up and down. X's deals with running left and right. So we would go from this point, we go up 1, 2, 3, 4, 5, 6, 7, 8. Again, up 8. And then we would run from here, we would go 1, 2, 3, 4. So that's right 4. That translates to +8 over +4, which must be simplified with a slope of 2. Now, points represented, find the slope of the line. So we could do a number of things. We can take this and we can write them as points, and then we can call this x sub 1, y sub 1, because this is point 1. And we can call this x sub 2, y sub 2, because this is point 2. And then you can use this equation, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So our y sub 2 value is -2 minus my y sub 1, which is -2. My x sub 2 is 2 minus my x sub 1 is 1. So that makes, we get 0 over 1, which has a slope of 0, different from no slope. So that's one way of doing that problem. We can take 2 points and do that. I'll show you another way you can do this problem. I didn't even clone it. Why did it not clone that page? Another way, and let's erase ink, clear ink. Another way we can do this problem is we can look at the increments. So that's +1. This is +0. And remember, rise over run is our y's. So this is our y variable and our x variable. So 1, which again gives us a slope of 0. And you can do that between any 2 points. You can do it between the next 2 points and you'll still get a slope of 0. That's +1, that's +0. Or we can even jump multiple points. Multiple points is going to give you +2 and it's still 0, which simplifies to 0 over 2. We're always going to do the y, the difference of y's over the difference of x's. We'll do it for this one also. So here we're going to add 2. Here we're going to subtract 8. So we get -8 over +2, which simplifies to 4, slope of 4. Let's do this gap. Let's do it between these 2 points. So we add 4 here, and we are going to subtract 10. So -10 over +4. Oh, Mr. Mac made a mistake. 4. Is that not 10? Oh. Oh, that's 16. Sorry. -16. -16. Sorry, I did -3 and -13. Not the positive there. My bad. Sorry. -4. We still get a slope of -4. Good. 5, find the slope and the y-intercept of the graph in a linear equation. So this is in standard form. Standard form is ax plus by equals c, and we would not be able to find the slope. We could find the y-intercept, but what I'm going to do is I'm going to move it to slope-intercept form. Slope-intercept form is in this form, y equals mx plus b, where we have isolated y. So if we start with this equation, 6x plus 4y equals 24, I'm going to subtract 6x from both sides. That gives me 4y equals -6x plus 24. And then we're going to divide everything by 4. And we get y equals -3/2 x plus 6. So my slope is -3/2. And my y-intercept is going to be 6. Cool. Here we go. So this is nice. My slope, this is in slope-intercept form, y equals mx plus b, where the slope is the coefficient of x, which is -3/4, and my y-intercept, my b value is going to be the constant being added and subtracted to my x value. And this only works when I have isolated y. So y is by itself, so I can pull that information. My slope is -3/4. My y-intercept is 2. This is another good one. So I have isolated y, and I can think of this as that, because my constant is 0, so my slope is 5, and my y-intercept is 0. Good. Those are good ones. Again, I've isolated y, so my slope is going to be the coefficient of x, which is the number in front of x. My y-intercept is going to be the constant, -2. That's good. Oh, whoops, sorry. I think it says then graph it. Sorry, identify the x-intercept too. Whew. Okay, so I didn't even read the directions. I was making assumptions. My bad. That's what happens. All right, so we're going to graph this. We're always going to graph our intercept first. That's -2. And then we're going to use slope. Up 1, right 2. Up 1, right 2. If I extend that slope multiple times, I was lucky and got the x-intercept also. That doesn't always happen, but in this case it did, which was nice. I'm going to move that point a little bit. Okay. And when we're graphing, we're always going to put arrows at the ends of our line to show that there are an infinite number of solutions. Then I'm going to label my points, and my points are this, and what's that, 4, 0? 1, 2, 3, 4. So my y-intercept and my x-intercept, because it wants my x-intercept, is 4. So identify the x-intercept. The x-intercept is identified. But because it was in slope-intercept form, I utilized that information, this information, to graph it, and then from that graph I was able to project the x-intercept, which was nice. This is in standard form. So standard form, we utilize this, and we're going to take that -0.2x minus y equals 1. We're going to find the x and y intercept. The x-intercept, we're going to plug 0 in for y. And for the y-intercept, we're going to plug 0 in for x. And we're going to simplify it. If you want to use the cover-up method and use mental math, that's fine. So we have -0.2x minus 0, because we're substituting 0 in for y. So we plugged a 0 in there. That's why it became -0, equals 1. And we get -0.2x equals 1. We can divide by -0.2, -0.2, and we get x equals -5, I think that is. Certain it is. 0.2 goes into 1. 1 divided by 0.2 gives you 5. Good, and it's negative. And for this one, we're going to substitute 0 in for x when looking for the y-intercept. So that becomes -0.2 times 0 minus y equals 1. This becomes 0 minus y equals 1. This is -y equals 1. We're going to multiply both sides by -1. To isolate the variable, we have to get y by itself, and that's my y-intercept. And I think it says identify and graph. Okay, so here's my graph. I'm going to plot my 2 points. I have x at -5. That's on the x-axis, so make sure you're dealing with the x-intercept on the x-axis. 1, 2, 3, 4, 5. And y is -1. I've got that. Let's draw a line. That was a horrible line, but that's okay. We will fix that. Better. Let's put arrows at the end of it, and let's label. When we are given standard form, we label 2 points. When we are in slope-intercept form, we are going to label 3 points. Slope-intercept 3, standard 2. Identify the x-intercept. So this is kind of tricky in the sense that it's not in standard form for a couple of reasons, but I'm going to put it in somewhat of a standard form in the sense that my x and y, technically a has to be positive and a, b, and c have to be integers. So a is neither positive nor is it an integer, but that doesn't mean you can't utilize this technique to find the x-intercept. They don't need to be whole numbers or integers in order to find the x and y intercepts. That does not. That is the reason why they have to be whole numbers, and all that other is for uniformity of your answers, meaning across the world. So you're going to have -2/3 x plus 2 times 0 equals 3. -2/3 x plus 0 equals 3. -2/3 x equals 3. And now we're going to multiply by the reciprocal, which is negative 3/2, negative 3/2, and we get x equals negative 9/2. That's my x-intercept. Find my y-intercept, negative 2/3 times 0 plus 2y equals 3. 0 plus 2y equals 3. 2y equals 3. Let's divide by 2. And we get y equals 3/2. So that would be my y-intercept. So, and we need to graph it. So we would graph those lovely, not clean problems, but it's okay. Negative 9/2 is negative 4.5. 1, 2, 3, 1, 2, 3, 4.5. That's here. And we have 3/2, which is 1.5. Let's connect them. Oh, that's nice. Look at that. Boom. Arrows. Label the points. Negative, we'll say negative 4.5, 0. And we'll say 0, 1, and 1/2. Just to be fun. Number 11. Function f of x equals 150 minus 8x represents the height and feet of a rescuer. X seconds after rescuer begins to repel. Graph the function and find its domain and range. Okay, so this is the remaining height. Height, 150 is the starting height. This is how, and this is the rate of descent. Repelling descent. And x is the seconds. X equals seconds. So if we have f of x equals 150 minus 8x, we can rewrite that as y equals negative 8x plus 150, where this is our slope. This is our y-intercept. And if we had to graph it, we're going to start at 150. How am I going to, what increments am I going to go at? 10, 20, 30, 40, 50, 60, 25s? No, because we're descending at 8 feet per second. Yuck. We're rate of 8 feet per second is our descent. Feet, seconds after rest. Well, how are we going to do this? 25, 50. No, that's not fun either. All right, we'll just extend this a little bit higher. So we're going to go tens. So this is 100 feet. That's 110, 120, 130, 140, 150. So at 0 seconds, this is x, which represents seconds. This is y, which represents feet. So at 0.0150, after 0 seconds, the person is still 150 feet off the ground. And after 1 second, what would it be? Well, it'd be 8 feet shorter. So after 1 second, it would be 142 because it descended 8. So you would have your second point. But let's find the the x-intercept. So we want the x-intercept. Remember, x-intercept, we substitute 0 in for y. So that 0 is going to go in for this value. So we set that equation equal to 0 because we want feet to be 0. When they're on the ground, they would be 0 feet off the ground. So it would look like this if we wanted to find that value. We'd subtract 150. You get negative 150 equals negative 8x. And 150 divided by 8 gives us an ugly number, 18.75. Right, divide by negative 8, divide by negative 8. What do we say, negative 18.5? 18 3/4. 18 3/4 equals x, and that would be 18.75 seconds. So here we are, this is seconds, and we need to extend also here. Yuck. Okay. Well, this is 10 seconds, that's why. Oh, yeah, 10 seconds. So 18 is going to be way out there. Can I move it all? I'm going to have to shrink and do some fun stuff on the computer right at the moment. Let's do this. Let's grab it. Make it smaller. Make it even smaller than that. Good. Let's grab the graph and chart. Okay. Let's move it to the side a little bit so I can extend. Now I can get to 18 point. So that's 10, 11. Let's move that. Can we move you down? Good. That's 11, 12, 13, 14. That's horrible. 14, 15, 16, 17, 18, 19. So right there would be when he reaches the ground, and that would be 18.75 comma 0. So after 18.75 seconds, that person is 0 feet off the ground. So that's what those values would mean. And would it be continuous or discrete? It would be continuous because, what? It would be continuous because you are descending, and you're descending at a constant rate of speed. So it would look like that. It would not go below. Does that look like it goes below? It does look like it goes below. Would not go below the x-axis. So it looks like that. Perfect? Good. That's a really good question. Interpret the terms and the coefficients. So I think we already did. F of x is the equals the feet remaining to descend. Descend. 150 is the starting height. Negative 8x is the amount of feet descending. And we can even break down that a little bit more. Negative 8 is the rate of speed descending. And it's descending at 8 feet per second, and x equals the number of seconds. Very important to understand all these terms, if you can, and the x-intercept. And we talked about the x-intercept. The x-intercept is going to be 18.75. And what does that mean? That is after, because that point is 18.75 comma 0. And after 18.75 seconds, they will be 0 feet off the ground. Great question. Really good comprehension here in understanding the problem. And notice it's 8 feet, it's negative 8 feet because you're going down. Find the value of k. So the graph of the equation, 9kx plus 2y equals 18, has a slope of 9/4. Okay, well, this is in standard form. 9kx plus 2y equals 18. So if I want this to equal m, I need to put it in slope-intercept form. So let's solve for y. So we're going to subtract 9kx. We get 2y equals negative 9kx plus 18. We're going to divide by 2, divide by 2, divide by 2. We get y equals negative 9 halves kx plus 9. So remember, m is the coefficient of x. So this would be my m value. That's what m equals. So if I need m to equal 9/4, I can set those two equal to each other. So we need negative 9 halves k to equal positive 9/4. 9/4. So I can solve it. Well, how am I going to? I'm going to multiply by the reciprocal, which is negative 2/9. Negative 2/9. Guess what's going to happen? That's going to cancel. That's going to cancel. And you get k equals negative 1/2. So what value for k, so that the graph of the equation has a slope of 9/4, k needs to equal negative 1/2. Another great problem. All right, good luck with that. Hopefully you're taking on these extra practice to strengthen your comprehension, because this is good reading comprehension problems. Good luck.